Welcome to Walkabout the Galaxy, the not-so-serious astronomy podcast where the science is universal, the opinions are personal, and the hosts are trying to catch up.
It's just one day at a time.
We are Strange Charm topping down the astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida, and we're with a virtual Jim. A virtual
Yay.
top.
Yay.
Follow us on Instagram and anywhere else we may happen to show up, which will mainly be Instagram, where the facts aren't checked and stories, like our collective memory, only last 24 hours. But they can be liked, so like away, and tell your friends to listen to the best astronomy podcast. Catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is an asteroid flod stumper.
Yes.
Flod, as you recall, is flyby, land on, orbit,
destroy.
Excellent. Today's stumper is a cheap stunt to remind everyone that there are asteroids named after us.
Yeah, this is going to be amazing.
So today, your choices are the following objects. Jim's going to have the most fun with this, probably. Asteroid 29605 Joshua Caldwell.
Mm-hmm.
Asteroid 27409 Addie Dove.
Mm-hmm.
Asteroid 28798 Audrey Martin.
Mm-hmm.
Sorry, Jim.
I don't have an asteroid.
That's
what
so
the hell?
sad.
And
I really did forget that Jim didn't have an asteroid.
asteroid. So our fourth asteroid is 52246
DJ.
Donaldjohanson.
Donaldjohanson.
Okay. So those are your four asteroids. Fly by, land, orbit, destroy. Audrey?
All right. Well, this is going to get political. No.
Podcast is over after today.
I want to orbit Audrey Martin.
Sure.
Okay.
Sure.
You don't want to land on Audrey Martin?
Do I get to orbit it before landing or
No.
Right. So I want to get a full shape of it. So I want to orbit.
Okay.
I think you usually orbit before landing. So.
Not in this game.
Okay.
Land on Donaldjohanson.
Okay. Because Lucy has just done a flyby of Donaldjohanson.
Right.
Spoiler
yeah.
alert for the rest of the pod.
Yeah. Right. So been there, done that. But it'd be fun to land on it.
All right. So now there's a problem.
I know.
Because she's going to destroy
One of us.
one of
Yeah.
us.
And and I do think
hard
that
'cause
my
we don't know
asteroid
as much
is more
information.
interesting than yours, both of yours, because mine has a lower albedo. So I just think that's like a lot more fun.
Sure.
Yeah. It's not just because it's mine. So for fun,
I don't remember anything about either of our asteroids, so.
I think mine's the biggest too.
Oh, interesting.
So yeah, for fun, we'll destroy.
Not if they got the albedo wrong, it isn't.
Oh, that's true. That's very true.
Snap.
Destroy Josh.
Of course.
Fly by Addie.
Nice.
Yeah.
Thanks.
Big
Thanks.
surprise there.
Yeah. Sorry, it took a
All right.
while.
Addie, what are you going to do?
I'm going to destroy Audrey
Oh,
because it's dark. Who cares?
right.
Wow.
Yeah. Hot take, dark asteroids aren't that interesting.
Oh!
Ouch.
They're like flames. I'm gonna orbit my asteroid. I'm gonna land on my asteroid.
Yeah.
I'm gonna orbit DJ,
Okay.
and I'm gonna fly by Josh.
Okay. It's better than getting destroyed, I guess.
Yeah.
I am going to land on my asteroid.
Yep.
That's a title of my next rock album.
There you go. Land on my asteroid.
Land on my asteroid. I don't know if that.
I don't know about
That's
that.
Yeah, I take it back.
Maybe it's
This
too
is one of
late.
the
It's
reasons-
just a song on the
it's what-
album.
Maybe so.
Yeah.
Yeah. But maybe this is one of the reasons, one of the many reasons I don't have a rock album.
Probably the main reason.
I'm gonna land on Audrey Martin,
Yes.
and I'm gonna like pick stuff up and throw it off
That's kind of fun.
the asteroid to make it smaller.
And won't make it that much smaller.
Oh,
It's
I'm
pretty
gonna spend
big.
some time there.
Okay.
It's not that big.
Okay.
Spend some time there.
And
What a weird threat.
I'm gonna fly by Donaldjohanson
Again.
again.
Great.
and orbit Addie Dove. I kind of feel like I've
boycotting this entire thing.
I kind of feel like I've been in
You're
Addie
just going
Dove's
to destroy
orbit
all of us.
for all this time anyway.
Thanks, John.
Yeah, that's the thing is I was going to destroy all of you, for not having an asteroid myself.
Okay.
That's fair.
That's
I'm
fair.
I'm angry.
We'll let you do that if you want.
Yeah.
Also, if I don't, it's a little awkward. It's a little too close to screw, marry, kill. So I'm gonna just destroy you all. How about that?
Okay. I think that's a little bit of a stretch, but that's fine. Yeah.
So you want to
we'll let you be pouty.
murder us?
We'll let you be pouty and destroy all of our asteroids. Yeah.
Yeah.
Well, today we will talk about ultralight dark matter. And I know ultralight dark sounds like an oxymoron, but it isn't. An update from the Lucy mission to the Trojan asteroids and much more. But first, this episode of Walkabout the Galaxy is brought to you by opposition. Don't let yourself just be carried along by the crowd. Chart your own path with opposition. With opposition, you'll find yourself fully illuminated by the sun to your friends back on Earth, and while they're going with the flow, you'll be enjoying apparent retrograde motion to show your independence from the masses. Show off your independence and opposition by being visible to your earthbound friends from sunrise to sunset, and have them marvel at your opposition effect right at midnight. Opposition. Never hide.
Never hide.
Never hide.
Some like high-vis
Flashlight.
vest thing or like a flashlight or...
Oh, like a running vest, like for
Yeah.
nighttime running?
Oh, yeah.
hide.
Yeah. I was actually kind of pleased that
Oh,
I
wait,
could
this
find
is
some
by opposition.
opposition, as in astronomical opposition.
Yeah.
When a thing is on the opposite side of the Earth from the sun. So it's brightly illuminated. That's a hint.
Yeah, some sort of light thing.
A light
That's what you
bulb?
were going with. Like
Yeah.
a flashlight or
Yeah.
something. Philips.
Philips light bulbs. That's Addie's go-to.
I don't think that's right.
I don't know what brand flashlights are.
Magna,
Flashlight brand, flashlight.
Magnum.
Jam, you got any ideas?
I got nothing.
You know what the opposition is?
Yes.
Yeah. So, yes, like when you're on the Earth and Jupiter is on the opposite side of the sun, so it's fully illuminated. So you
Yes.
might need some
Sunglasses?
sunglasses.
Oh, Ray-Ban.
Yeah.
Ray-Ban.
Never hide?
It is
Never
weird,
hide.
But like
right?
when you're
That's
wearing
weird. That's hiding.
sunglasses, yeah.
No,
you're
but
like
you got
kind
a
of-
lot of style, so you're not hiding.
You stand
maybe.
out because you're
I
like
stand
out.
so fancy.
I don't know. I thought it was kind of funny, but it worked for us
Tricky.
because the most visible objects in the sky, planetary objects in the sky, are when they're at opposition. They
Yeah.
are up the whole time the sun is down, and they're fully illuminated. So
Love it.
they're not hiding. So anyway, Audrey, last episode you had a hot take. Could you care to remind us what it is very quickly, Jim style?
Hot take. Hot take. Ice is a mineral. Hot take.
Thank you. So, and can you remind me what you had? You had two arguments for it, I think, or maybe just one.
It has a crystal lattice.
Okay,
Duh.
but what about amorphous ice?
Yeah, that is a thing. I think amorphous ice is not a mineral, just like amorphous silica, like opal, is not a mineral.
Really?
Oh,
It's a
Yeah.
rock?
silica.
What is it? What is opal?
I don't
Wait,
really
what
know.
is opal? Okay, you don't really know.
Yeah, it doesn't have the structure of the crystal lattice.
And so that's the defining characteristic for a mineral for you, crystal structure.
Yeah.
Is a dusty plasma a mineral?
It does have a crystalline structure.
Really?
Yeah.
Can.
Oh.
Yeah.
Okay, maybe.
Good
sure.
question.
But it's-
I like that
Yeah,
question.
thank you. But it's not a solid.
It's not
Oh,
solid.
well, I think it
Is
has
sugar
to be a
is
solid.
sugar a mineral?
I don't know.
Is it crystalline?
Can't you make sugar crystals? Right?
This episode
Well-
now called "Is It a Mineral?"
Yeah. Well, I mean, salt is. So
I'm just
I don't
wondering.
See why
I don't know.
sugar-
I'm an
sugar-
idiot. I don't have a horse in that.
Yeah, salt's just like sodium chloride,
Yeah.
where sugar's got a lot more atoms than that.
Okay, so it'd probably be harder to make a.
Yeah. We're now well out of our comfort zone. So to bring us back,
Yeah.
I've got my hot take. I have
Okay.
a second hot take. Hot take.
Hot take!
Contact binaries and peanut-shaped asteroids aren't interesting or surprising. They're just what you would expect. Run-of-the-mill, ordinary, small asteroids are going to be shaped like a potato or a peanut, and everybody should stop congratulating themselves for finding a peanut-shaped asteroid.
Ooh, hot take.
Hot take.
Wrong.
Dynamically, he's not that wrong.
Wrong. We've only been to like a handful of asteroids.
And
Each
they're
new
all like
one.
that.
That's not true.
No, I
All
know.
different.
But the
We have
medium,
a lot of asteroids
the-
and comets with necks and,
Yeah,
and
yeah.
contact binaries.
Yeah, contact binary
Right.
shapes, which is
Yeah.
interesting. It's an
That's
interesting.
not interesting. That's my hot take. It's not interesting.
Wow, I
think
really
it's
disagree
really,
with you on that.
Really interesting.
I think it's okay to say they're not uncommon. I don't think it's okay to say they're not interesting.
Yeah.
Okay.
Well, I mean, you can say whatever you want.
Thanks.
Let's go past 100 asteroids or 1,000 asteroids, and then we can build up some statistics. And then adding one more to the mix isn't really going to be that big of a deal.
All right. Well, Audrey, would you like to tell us what's interesting about a neck-shaped contact binary asteroid?
I should note that I am not speaking as a representative of NASA or a representative of the Lucy mission.
We just flew past another one.
What?
Woo!
I
Yeah.
flew by
Exciting.
it. I flew by it.
Yeah. Well. Okay. Yeah.
Donaldjohanson.
You flew by it, and I
52246 Donaldjohanson, the Lucy mission on its way to the Trojan asteroids, which it gets there in like a year and a half or 2 years.
I think in almost exactly 2 years. I think it's April-ish 2027.
So-
It's 2027.
Right. So
Yeah.
the Lucy mission is going to visit 8 asteroids that are sort of sharing Jupiter's orbit. Right.
Well, it depends on how you count it, but yes.
And
Because
they're- and
some of them we've
those
been
have
finding.
moons.
Yeah, some of them
those
we've
have
been.
moons.
Mhm.
Right. So
Yeah,
it's
yeah.
more than 8 actual objects
Yeah.
will be
So
seen.
5 flybys, 5 Trojan flybys.
Oh, really? I thought
Mm-hmm.
it was more flybys than that.
4
Four
in
on the one side.
4 in on L4. So we're going out to the L4 swarm now.
That's the trailing.
Leading, and then
Then
swoop
come back into the Earth.
swoop back to Earth,
Crazy.
and then hit up L5, where the binary, not contact binary, but binary, Patroclus and Menoetius are
Gesundheit.
thank you, are orbiting each other,
Okay.
and that'll be in I think 2032 maybe.
The
Okay.
second one.
Right.
When's
so
the first one?
27.
2 years from now.
Yeah,
And those are all flybys.
yeah, all
There's
flybys.
no,
We're not gonna
no
destroy
orbiting,
any.
no destroying,
no destroying,
landing.
no
Yeah.
landing. Yeah.
But on the way, it just flew by its second main belt asteroid.
You know what it is
Yeah.
orbiting? The sun.
True.
It is orbiting the sun. Yeah, it just flew by Donaldjohanson. This was the second main belt rehearsal flyby because the flybys happened so quickly.
Everything's got to go right.
It's got to go right. So we have the opportunity to fly by 2 different asteroids, Dinkinesh and now Donaldjohanson, and like test out all of the different science sequences and make sure that we can turn the spacecraft in the right
Right.
way and get the data in the right way and make sure that all of the way that we're collecting data are going to be useful to do science with once we get to the Trojan swarm. So we were able to do that at Dinkinesh, and that was really exciting and really fun. And now with Donaldjohanson, it's also very exciting. Very
and it
fun.
worked.
And
It
it
worked?
worked.
It worked?
Yeah.
It
I'm
totally
excited.
worked.
I hadn't read about it, so I'm very excited to hear
Oh,
about it.
I was
God.
ogling the image, the press release image.
Sure.
Yeah.
Man.
Off
I
and
didn't
on
see
for
it.
days.
I didn't see it. Why
You
did I
didn't
not see it?
Jim?
Oh,
Aren't you
I
like
didn't
a
see
aren't you
yeah.
like a professor of astronomy or something and teaching an
Yeah,
astronomy class?
yeah, but I didn't see it. I didn't see it. I didn't see it.
Wow.
Well,
But
it's
no, really nice
well. Josh
pictures.
thinks it's boring.
I think the spacecraft performed from what's been released publicly.
Yeah.
Looks like it performed beautifully. The pictures are in focus. The asteroid's in the middle of the pictures
Yeah.
or whatever.
Yeah, exactly.
And
which
they're
is
nice- they're
yeah,
nice
which is all
pictures.
great. And like
Yeah.
we've talked about other missions and stuff that things don't always go to plan. So it's very
Yeah.
very exciting when they do go to plan.
Yeah.
Yeah, there's lots of cool structure you can see in it. There's like we were talking about. It seems
It's-
binary, contact binary.
Yeah.
There's like craters. There's like boulders. There's like different ridges. There's lots of stuff.
Yeah, there's so much stuff. And we've only had these pictures for like what 5 days now.
Something like that, I guess.
And
Yeah,
Yeah.
we're
How was 420 in Boulder? Nah.
that was the day of the flyby.
yeah, that was the day of the flyby. I was inside all day.
Yeah. Today, we're recording this on April 25th, which I'll point out is the 30th anniversary of the deployment, 30th or 35th? 35th anniversary of the deployment of the Hubble Space Telescope.
Oh, happy
Really?
35th birthday, Hubble.
Oh.
Oh, I think
Yay.
Lunarvise did an Instagram post about that.
Yeah.
Fun.
So that was Sunday. This is Friday. Yeah.
Yeah.
And so everything went well. You were in the room where it happened.
I was in the room where it happened. It was very
That's so exciting.
Yeah,
Yeah.
it was super cool.
Yeah.
It was very interesting and
Were there eruptions of cheers when pictures first appeared and that kind of thing? Was it that kind of moment?
Yeah, absolutely. It was super, super exciting because this is something that no human eyes have ever seen.
Right.
No
Yeah,
human
what was,
ever
like,
has
so
ever
we
seen
knew
it.
DJ was there. What kind of spectra did we have leading up to this? Or images did we have leading up to this?
Just light curves.
Just light curves.
Wow.
So
Okay.
we know that it rotates with a 10-hour period.
We have
a
radar.
10-hour period.
Yeah. What?
Do we have radar?
I don't think so. I
That's
don't know.
too far.
I don't think so. Yeah, it's at
Oh.
about 2 point something AU. So yeah, it's kind of a little bit far. So we knew its rotation period.
We have radar from
We have
Saturn.
radar for main belt stuff.
Yeah.
Well, I
So
don't
anyway.
know. But no,
Okay.
maybe no one
Probably not.
wanted to look. I don't know. There were some like ground-based spectra, but it's hard to get spectra from
Something
the ground
that
of
small.
something that's that small. It's 8 kilometers in one direction and about 3 kilometers in the other direction. So it's pretty little. And so we knew it was roughly like C-type asteroid, so carbonaceous. It's a member of the Aragone family, which we've talked about before.
Origami.
Yeah. And so we know it has a family, and there's been a lot of studies on origami before. So we knew that. But other than that, not too much. It was just in the right spot for the spacecraft to go
Right.
past it and
What
not
was the-
spend too much
What was the
energy.
closest approach distance? Like about 600 and some miles or something like that?
Don't actually remember. I think that is.
Yeah. And so paint a picture. You're in a room. How many people are in the room?
There were quite a lot of people during the Dinkinesh flyby. Not too many people were there. I wasn't there either. But this time it was there were like a lot more people, and
I'm still waiting for a number, Audrey.
I don't know how many people.
Okay. Were there 20, 9,000?
100.
2?
There were probably about 100. I don't know.
Okay.
I'm not sure.
And it's what time of day?
It was so the flyby happens.
I'm talking about the moment when you see the first image.
The moment of the first image was at like 2-ish, maybe.
2 in the afternoon.
In the afternoon.
Yeah, in the afternoon. Yeah.
And everybody's just sort of waiting with bated breath for
Yeah.
an image to appear on the screen.
Yeah. Yes.
And
Exactly.
Did
was
you
the-
get like a full frame image, or did you get like a little thumbnail at first?
I think it was the full frame at first. There wasn't much detail, so we got like kind of the general shape of it.
It was a distant, not like, it wasn't the best first.
Right, yeah.
Right.
So like we saw the like general shape, and then the more close up, more in focus, detailed images came down after that.
How
much
long does
after?
that take? I
Yeah.
remember when New Horizons flew by Pluto. It was a long time before they got the really high resolution stuff because it like took forever to get that data down.
Well,
That's
right.
much
Yeah.
farther away.
Downlink
It's much,
issues.
yeah, it's much farther away. But it was more like the data rate was
Yeah,
really
yeah.
low.
Because it's
was
so
that
much
true here
farther
too?
away.
But it's partly because you have to like
Well,
have more power to pump it
right,
to get it.
Right.
It's sort of-
Okay.
Yeah. It's just the data rate.
Not just like well, it's not. Yeah, it's
It's not
not just
light travel
time. It's data
It's-
rates you can get from further away.
Right.
Right. Okay.
So
Yeah.
what was the duration? So like you see that first thing, like, hey, it's working. We took a picture. And then when do you get like an amazing picture and you're like, holy cow, it's another peanut-shaped asteroid. Josh Call is going to be hating on this thing.
I think it was within an hour.
Okay.
Yeah.
So that's a pretty exciting time period then.
Oh yeah, definitely. Yeah,
Yeah.
it was very, very exciting.
Cool.
Yeah.
That's awesome. Well, listeners can check out unlike Jim,
Yeah.
our listeners are paying attention
I
to what's going on.
I just checked it out because Eddie sent it to me. It's cool.
Yeah. You can just Google Lucy Donaldjohanson.
Yep.
And you will see these cool
Yeah.
pictures.
Yep.
Before we get into our astrophysical topic, I will give you your trivia question. This is one of Jim's favorites.
I hope it's a rocket one because those are the only ones I win anymore.
Right. Well, it's rocket adjacent. It's about
I would
satellites.
like to be rocket adjacent.
We mentioned that it's the 35th anniversary of the deployment of the Hubble Space Telescope, which is
That's
still orbiting the Earth in low Earth orbit. There are about almost 12,000 active artificial satellites orbiting the Earth right now.
Crazy.
Oh my God.
Could go back to like some of our earlier episodes where that number was like 4,000.
Yeah.
The question is, and those are like we talked about Starlink and all those things. They're in what's called LEO.
Low Earth orbit. They're
That's
not
where-
in the constellation Leo in the sky.
Thank you.
Yeah.
And that's where the space station is, and
They're in different orbits than the space station, to be clear. For the
Different
most part.
paths, but they're in the realm of space we call
Yeah.
low Earth orbit. How many of those satellites, though, do we have in what's called geosynchronous orbit?
Geo, which is called Geo.
Geo,
But it
as
should be
opposed to
called
Leo.
GSO or something.
Well, yeah, could be. Yeah, that's true.
I think it's
No, you're
geosynchronous
right.
Earth orbit, so it is Geo. Got it.
Okay,
We're fine.
that works.
Everything's great.
Good.
Yeah, and some people make a distinction between geosynchronous and geostationary.
Oh, yeah.
Geosynchronous means your orbit period is equal to the rotation period of the Earth, which is 23 hours and 56 minutes and change. Geostationary means it's that and you're over the equator, so that the satellite is stationary in the sky from your point of view, wherever you are on the Earth. But geosynchronous could be bouncing back north and south over the course of the day.
Oh.
Okay, but we're lumping all that together. Geosynchronous orbit, GEO. Your
Geo.
trivia question is, how many are in GEO, and what's the closest physical separation of satellites in GEO? And then our follow-up will be about MEO.
Moon?
MEO, so special.
No. That was awful.
Thank you. So,
What's Mio?
well, we'll come back to that when we're giving our answers to the GEO. Yeah.
Moon, Earth, orbit.
So, did you have any other space news? Because we kind of went straight into Lucy.
Which is space news.
Right.
Yeah.
Yeah.
Space news. There was a cool image that came back. I feel like this is space news. There
Yeah,
was
let's
a cool
do it.
image that came back from a Mars orbiting satellite. Sorry,
Oh,
I'm trying to bring
yeah.
it up right now. That I can't find it in my screen. Which orbiter took it?
I think it was MRO, but I'm checking.
MRO, the Mars Reconnaissance Orbiter, took a picture of Mars as it's wont to do, and it snapped a picture of Curiosity,
The rover.
the rover.
And it's
And apparently-
track.
While it's like
Yeah,
tootling
MRO.
Well,
along.
it's driving, technically.
Yeah.
It's a still image, so you can't
Yeah.
tell that it's driving, but you can still see its tracks,
Yeah.
which I was thinking about. I was like, we have all sorts of images from LRO of like tracks on the surface.
From like
So
Spirit and
how-
Opportunity even.
Yeah, and like, but like,
Oh, not for LRO, but
from,
yeah.
and we have images from like Spirit and Opportunity, but I guess maybe we were taking them. We haven't taken one like this of Curiosity before, which I find
This
hard
one-
to believe.
Yeah.
Well, they were the news reports on this one were like, or NASA, I suppose, is where the original blame lies, is like hyping it. This is the first time we took a picture of it while it was actually moving,
Yeah,
right.
which is completely beside
irrelevant,
the point
really.
because it's moving along at a very slow pace and you're taking a picture of it from orbit and it's a snapshot. So
Yeah.
you can't actually tell it's moving or not one way
Yeah.
or the
Yeah.
other. Yeah.
But we
So
know
how high? This is the Mars Reconnaissance Orbiter. That's been up there for a very long time, though, right?
it's in there so long.
Yes.
How high above Mars? It must be in low Mars orbit. then.
Yes.
But you can orbit a lot closer to Mars than you can Earth because there's no atmosphere.
Right. Well, there's
Well,
some.
not no atmosphere, but much less atmosphere. So what? How high above is it?
Oh, that's a good
No
trivia
idea.
question for a future episode.
Oh
Yep.
shoot! I had no-
Actually,
yeah,
it's
I had no-
probably a mediocre trivia question for a
It
future
would, be,
episode.
it would be a mediocre.
Yeah.
one, I guess. Audrey, are you looking
But I
at
am
it?
curious about it. I know that like LRO and moon observing orbiting satellites typically are at about 60 kilometers above the surface of the moon, which is well above the highest mountain peaks on the moon. And there really is no atmospheric drag you have to worry about on the moon. And
No,
I-
but on the moon, you do have to worry about weird gravity,
right.
and it makes orbiting actually really
Tricky.
challenging.
Yeah, I think there are some advantage. There's when you get closer to the surface, there are some complications that you run into, even independent of an atmosphere, and even really independent of topography, and accidentally like running into a tall thing. So, I think
But to-
there's.
I mean, to
think
have
there's a
that-
sweet
Generally
spot.
around an orbit of like 2,000 kilometers.
Oh, that's high.
Well,
That-
yeah.
That is high because to be able to see a thing that's, I mean, Curiosity is only
Its
a few meters
closest is like
across.
426 kilometers, and the farthest is like 3,800 kilometers.
Elliptical orbit.
So it's got an
Oh,
elliptical orbit.
interesting.
Yeah.
Okay.
Yeah. Okay. Well, I hear there's some news about ultralight dark.
Oh, can I finish really quickly? Sorry.
Okay.
We got distracted about how high it was. But I was going to say,
That's Jim's fault.
but I was going to say,
Sorry.
it's interesting because I was thinking about it too, in terms of like, we've gotten pictures of it on the surface before and of the other rovers, as you mentioned. And I just love spacecraft taking pictures of other
others,
spacecraft. And it's just so great. Or of themselves. That's fun too.
Oh, yeah.
But it is cool that you can see the tracks because actually on Mars, tracks don't last as long.
Right.
They get wind blown and stuff like that. So like,
Unlike the moon
that's
unlike the
true.
moon.
stuff, right.
So like it is cool to capture and see where it's driven and like you can see it's sort of not quite a straight path. And, I don't know, it was fun.
Yeah.
And there's just a lot of cool topography and what you could see on the
Yeah.
image, so.
Yeah.
That's all. We can talk about other space things now, Jim.
Ooh, space things. Farther away in
Much.
space and time. So, we've had this issue recently of like, we see really big black holes in the very early universe.
black
We've
holes.
talked about that a few times.
Yep.
Big black holes.
So I wanted to kind of see if I could lay out the real reason why that's such a problem, because
Please do.
you can make, how do you make a really big black hole? Obviously, you don't make the really big black holes in the same way we make normal black holes. It's not the collapse of stars that does it, but it's similar. It's the collapse of big clouds, probably of hydrogen,
or
dark matter,
or it's the merger of a bunch of smaller black holes.
or the merger of a bunch of smaller black holes. But that is for the really early black holes. That's not too reasonable because there shouldn't have been enough time to make all those stars and have them all collapse together. And so you could theoretically make it like that, but that's very
we
challenging.
have to put all the if we're going to start ruling stuff out, we got to put all the possibilities out there. Then we got to rule them out.
Absolutely. Yep. But the problem with collapsing a big cloud of hydrogen and making a black hole in the early universe is when you collapse big giant clouds of hydrogen, collapsing things heat up and
Stop collapsing.
well, that's partly the problem. But actually, we don't want them. We actually, if they're not hot enough, so if they cool off, then what they tend to do is, because when big clouds of stuff are collapsing, it's not like they're only collapsing on a very big scale. There's also smaller scale collapsing going
so
on.
there's fragmentation of the cloud.
Right. So fragments. And you don't want that if you're trying to make a big giant black hole. You want the
Right.
whole thing collapsing. And so you
This is-
actually want it to stay pretty hot.
This is
and
why we
not
end up
cool.
with star clusters.
That's right. So if you want to make stars, it's great that happens, and you want to cool off your thing, and then you'll have all those. But if you want to make a big black hole, you need to keep it pretty
Big black
hot.
hole.
I want to make a big black hole, and I was wondering, but the problem is when you start collapsing down hydrogen, you start to get a lot of molecular hydrogen because the hydrogens are starting to interact, and molecular hydrogen does a really good job of
Radiating.
cooling off, radiating energy, right? Because it has all these modes that like to radiate energy away. So it does a really good job.
And so
what you
just
need, if you really
just to
go ahead.
sorry.
No, go ahead.
Sorry, not sorry. So if it's cool, what happens is it's easier for things to collapse under gravity. Heat causes things to puff up, basically. And so the overall weight of the giant cloud of hydrogen is making it collapse. And if it's hot, it's not, the smaller pockets of it aren't able to collapse themselves because they're too hot to do that. And when they cool off, then a smaller thing can fall in on its own weight and it makes a smaller object.
That's right. That's exactly right. So it sounds almost paradoxical. You want to keep it hotter if you want to collapse the whole thing because you don't want the little bits collapsing. So you need some mechanism to break apart the molecular hydrogen when you start to make it if you really want to make a lot of black holes earlier. And so that's where this dark matter comes in.
The molecular hydrogen is better at cooling off than atomic hydrogen because it's got vibrational modes of energy that it can use to it's got other ways that it can be hot, and so therefore it's got other ways that it can radiate that energy away.
Right. That's exactly right. You're on top of your stuff here, Josh.
Thank you.
Good job.
Nicely done.
Very nice.
Should
He's
host a
explaining it a lot better. Yeah,
Should host a podcast
so this
or
is where the
something.
dark matter comes in, because so there are a couple of different mechanisms that have been suggested recently where dark matter could produce the high energy radiation that you need to break apart molecular hydrogen. And one of them is this a recent article about ultralight dark matter, which is basically dark matter made of particles that are like way, way, way less massive than the least massive things that we know about, which are neutrinos.
Wait a
so
minute.
If you
what?
have
Less massive than neutrinos? Like I
Yeah.
already
Just
thought
broke
that,
his brain.
I thought all of the candidates for dark matter that were seriously considered these days were already like ultralight. Like we talked about, like, are they called axions is one of them?
Yep.
yeah.
And aren't all these things like super, super, super tiny, to use a technical term?
Well, they're all tiny, but they're not all necessarily like
Low
less
mass.
massive than neutrinos. Things like, that we had considered those supersymmetric particles and stuff that we thought about that you would make in the
yeah.
LHC and stuff. Those are I mean, they're obviously subatomic particles, but they're not ultralight. These are
Okay.
These you could go hiking with.
Right.
yes.
Take as many as you want.
Yeah.
But without going into any gory detail, those very, very ultralight particles can do fun things like make waves, and then in the densest part of those waves, the dark matter can transform into high energy radiation, and then that breaks up anyway. So we're looking for
Wait a
ways
minute.
to break up that molecular hydrogen.
Anyway, I don't know. I mean, sorry. So I lost the thread there because then you just kind of like hand waved it away.
I
So-
did.
Addie
I did.
can't
And I
wave
was
it
also
away.
doing hand waving.
Maybe that's why I got confused.
You guys
So-
are having fun. I'm glad. I'm glad you're enjoying
Yeah.
recording the podcast.
So if you're, so for some reason, this ultralight dark matter helps break up the molecular hydrogen. That's what you said.
That's right.
And
It's not. Yeah, it's the dark matter because as it decays or as it turns into, because dark matter itself won't break up the hydrogen, but a high energy radiation will. And so if you can find
Oh.
a kind of dark matter that will turn itself occasionally into high energy radiation, then you can break up the hydrogen. Then you can collapse everything down. And so
Okay.
it's turning itself into radiation E equals MC
Classic E
squared-ish.
equals MC squared.
yes,
Classic.
yep.
Classic
Yep.
matter
Leave it to ultralight dark
turning
matter.
into radiation.
Yeah. Okay. So it's very low amount of mass, but it's enough so that when you convert all of it into a photon, that photon splits those two.
That squared,
That's right.
that C squared
That's right.
makes a big difference.
It does.
Yeah, C squared is big.
Yeah.
Big, man.
But nice thing about all this is, like, you remember every time you saw a thing like there's too big of a black hole in the early universe, everybody's like, oh, we have to totally get rid of our whole cosmological model.
Roll
Right.
light physics.
Right.
That's not really true. You just need to find, it's probably you can fix it up
There-
with things like this rather than trashing
You
the
can
whole
put a
model.
bow on it.
There's
and then
probably
make it-
something
Yes.
else out there that we don't know about.
Yep, that's right.
Oh.
Okay. So
Man, science, whenever we figure something out, it always just makes us have more questions.
is this sort of avenue to explain early big black holes a oblique clue to the nature of dark matter then?
It could be, right? So it could be that we should be looking for very, very, very low mass particles, which are going to be
That seems
harder
hard
to
to look
find
for.
than if they're bigger.
Great.
Convenient. Are they also
Yeah.
string-like?
Yeah.
They're very low mass and sort of long and extended.
Are they the kinds of things? Do they just say, oh, okay, well, if dark matter has this kind of mass, then everything is okay? Or are there theories that
Yes.
say it's this kind of particle?
No, it's more just like I'm making a kind of dark matter that can solve the problem,
Okay.
rather than I'm borrowing a solution from somewhere else that would also solve my problem. So
Oh.
it's quite ad hoc, and so it's not terribly satisfying yet, but it's it's interesting thought.
It's about as satisfying as a peanut-shaped asteroid.
That's right.
Yeah, I
That's
don't know
right.
about that.
That's right.
Less satisfying than a peanut-shaped asteroid?
Peanut-shaped asteroids are great.
I'm really hungry.
All right, let's see what you think about satellites in geo.
I think they're useful. They have a lot of useful purposes.
They do.
Yeah.
Yeah. How many do you think are up there?
So you said something around
There's about 12,000 total satellites.
In
active
orbit.
satellites in orbit. now.
active satellites. Are we
Yeah.
only counting active?
I don't know because I couldn't find, so our numbers are, I don't know how many inactive
Little hand
ones there
wavy.
are.
Order
yeah.
of magnitude.
Yeah. Better than order of magnitude, but not better than
So
a factor of two.
something around, I don't know, like 8,000 of them are Starlinks. So so that means there's like less than 4,000 others. There's around 4,000-ish others. That are going to be some LEO and some GEO. So I'm going to go with 1,500.
1,500 in GEO.
Okay. 1,000.
Audrey's going 1,000. After that big assist from Addie, I'll point out.
I thought of 1,000 before Addie said anything.
Oh,
Great.
Dude,
And
I was also going to answer 1,000, but
Yeah.
I'm going to go 700.
okay. Once again,
Jim!
Damn right. You're damn right.
529 is one number I saw as of
That's a number I've seen before, too.
as of March 2025. I saw a slightly larger number as of
Whoa.
like 2023.
530?
It-
I've seen that
no,
number
like
before.
580.
Wow.
But I've seen 580 too.
No.
But 500 or so.
Sure.
And most of those are over the equator. So they're mostly geostationary. And so they're all on circular orbits in the same orbit. We were talking
Yeah.
earlier about
ISS.
ISS is not the same orbit, right? These are really in the same orbit, most of them.
Wow. That's
So-
hard.
So they're marching along, right?
Mhm.
So how close are the closest two to each other?
Wait, assuming non-collisions, because the closest they've come is collision.
Have there been satellites in GEO
Oh, I
collide?
don't know about in GEO.
I don't
Probably.
No
think so.
way.
Yeah. So these are like
Why not?
satellites that are up
We were
there
pretty
now in
Mhm.
orbit. There aren't any colliding now.
No.
So how close are the closest
Yet.
two in GEO now?
1 kilometer.
That's a reasonable guess.
Thank you.
500 meters.
Jim?
500 kilometers.
Oh,
It's
it's in between Audrey and Jim.
It is between Audrey and Jim. It's 73 kilometers.
Okay.
And
I think Audrey's
Oh,
closer.
yeah.
Then.
Yes.
she's closer on an
I'm
absolute
closer
scale, but not
logarithmically.
Yeah.
Yeah.
No, Jim's a factor of 7 or 8 off, and she's a factor of 70 off.
Why can't I just have one win?
Just,
You got to be there
She's
with an
closer.
asteroid flyby.
That's true.
Yeah.
That's why.
I win.
Take that win.
The year.
Audrey.
Yeah, you guys have asteroids named after
Oh
you.
yeah,
Right.
that's
There
true.
we go.
You're
True.
okay. All right, Jim. That,
Um,
I'll let you have this one.
One of the
we
limits.
should get an astroquark asteroid.
One of the actually I was going to point out, because I was like doing a humble brag about how we're about how we have asteroids named after us, but just to bring us all down a notch, if you look at like the next number next to yours, it's usually like a 7th grader who came in second in the science fair. It's like Joshua 29605. Joshua Caldwell. Joshua Caldwell is a Pegasus professor of physics and planetary scientist, studies asteroids, blah, blah, blah. 29607. Mark Johnson came in 3rd place in the Illinois Science Fair
Yeah.
competition.
Anyone can have an asteroid. It's not like
Not Jim.
Well, Jim can.
Apparently, everyone can't have an asteroid.
I'm just saying. And then if you look, it's like the lower numbers are reserved for people that the special people think are specialer.
Well, I think the lower numbers have just all been named already.
No,
Really?
Really.
What's the cutoff? Is it like 3 digits?
4-digit people are specialer than 5-digit people.
We're like a 10-digit people. I'm just kidding.
Um,
Many digits.
So one of the limits on
I need
how
to get
close
another
these
asteroid.
satellites can be to each other
Oh, right.
isn't. I mean, obviously you don't want them to crash into each other, but the other one is they're two-way communication,
Mm-hmm.
and so the beam size you don't want to make sure that your beam
You're talking to
that's-
that satellite.
satellite isn't interfering with the signal.
Oh.
Yeah.
So, and then it
Right.
depends on like if they're in different frequency bands, then they can be closer and it's not such a big deal or whatever. So that's one of the reasons. Guess what, folks?
I mean, I guess such a big thing because like it's low Earth orbit and geosynchronous orbit are very, very different distances
say
away
that.
from Earth. The circumference of that orbit is very large, and so
Right.
Yeah.
you could spread 500 satellites over a really huge distance.
Then
Right.
you
They don't
get,
have to be close.
yeah.
Except you want them to be over particular. Having one over the middle of the Pacific Ocean isn't going to be super helpful to a lot of people. Isn't going to be helpful to
That's true.
a whole lot of people, right? So
Right.
certain areas are more interesting than other areas for folks. So, Jim, you're going to have to wing this one on this one.
You got it.
While it may have felt like looking at all the pictures I took at a Rolling Quartz concert, it was just another episode of Walkabout the Galaxy.
Okay. Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Can't read that. Our theme music was composed by Richard Jurusik. Production assistance is provided by Logan
I
Basinger.
knew you could do it,
Thanks
Jim.
to our listeners in Canada and around the world. I'm Addie Dove.
I'm Jim Cooney.
I'm Audrey Martin.
And I'm Josh Caldwell, sad producer of Walkabout the Galaxy. We're the Astrocork signing off until the next episode of Walkabout the Galaxy.